That's because he's been introducing himself as an assistant speaker, which I'm not sure what that means. This is Ben right here. We're Brandon and Andrew. So who am I slide? I'm Brandon Arvanaghi. I'm a security engineer at Gemini.com. I used to work at Mandiant/FireEye as a security consultant there. I wrote a tool called Check Please, which was an implant security framework, and Session Gopher while at FireEye. And before all that, I did security engineer work at Vanderbilt. I went to school there and I studied security.
Hi everyone, my name is Andrew Johnston. I'm a proactive consultant at Mandiant, and I focus in red teaming. I also work at Fordham University as a researcher, looking at how we can use artificial intelligence to help fight terrorism. Apparently I hacked a toaster at the age of 5, and yeah, my alma mater is Fordham. I don't have a fancy headshot like Brandon does, so instead I just went with Sad Eyes Harold.
So, basic disclaimer, you're responsible for what you do and the information in this talk, thank you. Don't do bad things. And the case studies that we provide here are high level. They don't reflect any clients that either of us have ever worked with. And facts have been changed. Legalese, read this at some point. Malware fundamentals, very, very basic stuff. 2 high-level buckets for most malware. Malware that knows what it wants to do without any other input from the attacker. And these are really nasty ones, right? So ransomware, most of the time doesn't need to call back home. It just locks things up and it'll say, this is a Bitcoin address, pay me. Or something like to delete all files. You don't need someone to be at the keys to help with that. And then there's malware that does. So malware that wants to phone home. It can extract data or accept commands like in a remote access tool. That's more involved. That's when someone wants to snoop around, etc. So that's more targeted, nuanced. It's not reckless like ransomware or deleting all files. Of the malware that does need to communicate home, there's a couple different ways it can do so. The old school way was synchronous communication, basically a live stream of data going back. It actively listens and responds to requests. And there's also asynchronous. So that's malware that polls. You can set sleep intervals on this kind of malware. You can set jitters. You have more fine, you have more granularity with this kind of thing. Let's talk about being in sync now. So you're all familiar with the bind shell. It's very basic. So this is an example of synchronous malware. You can tie a shell to a specific port on a local computer and listen for, and tie the shell there and listen for outbound incoming connections. And it's very trivial to detect if there's a shell listening on a local computer. I mean, the workflow is there an open port? Is there a shell listening on it? I've concluded that there's a shell listening on an open port. Reverse shells got a little bit more interesting, but still in some ways outdated. This shell gets pushed out to the attacker's machine. So rather than having it tied to a local port, the shell gets pushed out to the attacker's machine, so you don't actually see the open port on your own end, and it's not tied to any port there. It's more difficult to detect because of this, and most synchronous rats are based on the concept of a reverse shell. So synchronous traffic was very basic. It started out with bind shells, moved on to reverse shells. It started out with obscure ports, and then that got easier to detect, so it went to regular ports you're used to seeing, like 443. Rather than just having one C2, you'd have some failover C2s if your first one went down. And another improvement was people started using C2 servers that are nearby. So if you're attacking a company in New York, you'll set up in your cloud environment, for example, a New York IP for a C2. So it looks similar enough. So the problem, one of the problems with synchronous traffic is that it's one long conversation and it's very loud and obvious in network traffic. It's essentially like streaming Netflix to a C2 server. So this is why we're seeing the shift to asynchronous. This is all very high level stuff. I'm just giving an overview for the talk. And it's very, very difficult to manage several reverse shells at the same time, and they're flimsy, because if one of these streams gets broken up, then you're in trouble. You have to find another way to beacon back. Now I will pass it off to Andrew to talk about asynchronous malware.
All right, so asynchronous malware is probably the kind of stuff that if you're doing red teams today, this is the stuff you're using. One of the nice things about asynchronous malware, since it is calling back to you, is that you can set working hours. You probably don't want to send any commands at 2 o'clock in the morning, so you can effectively shut your malware down and tell it not to beacon back to you until 9 a.m. or whenever you're going to start using it again. And that gives it the ability to look almost normal, because you can start to mirror what looks like normal organizational traffic. It's still not perfect because you have to call back to the server, but it's definitely a lot better than what we were seeing with synchronous malware. Right? The primary feature of these asynchronous malware softwares like Cobalt Strike, like Interpreter, like PowerShell Empire, is that it's making a new connection for every communication. It's not a long stream, but rather a series of discrete communications over time. So there's been a lot of work recently into making asynchronous traffic look a little bit more normal. There's been a whole bunch of articles on domain fronting, right? Domain fronting is when you're using a cloud provider to look more normal, and you can look like you're sending traffic to some pre-approved domain, but it's really going to your C2 server. If you've ever tried to implement this, it is rife with problems. You have problems with caching, and also a lot of the common targets that people use for domain fronting really don't like that their servers are now being used for malware, and if you try to do this, they will likely detect you and oftentimes shut you down. You can also improve yourself a little bit by implementing jitter. Jitter is a little bit of randomness into how often you call back. So instead of calling back every 5 minutes on the dot, maybe sometimes calling back at 4.5 minutes, and other times maybe not even till 6 minutes. And this gives less normalcy to the traffic and tries to obscure another artifact that defenders might be looking for. Another thing you're going to see talked about a lot is domain categorization. There's a host of different companies that offer this for enterprises, and it's a third party that tries to manage a whitelist for you and tries to group all the domains that your employees may be visiting. This allows employers to lock down machines and say they can only visit websites that have been pre-approved. But this really becomes a cat and mouse game. Just like everything else in security, there are a ton of vendors that offer this. And you can try to get your website categorized, but it's ultimately a guessing game, and you have to hope that nobody does some inspections or asks the company to recategorize it. Ultimately, this asynchronous traffic is going to look weird. The problem is that whenever you make a new domain to handle this kind of traffic, it's going to go from having no hits and nobody visiting it ever to all of a sudden dozens of workstations and maybe even some servers will all be connecting to this one system multiple times a day. This is really weird if you're looking at like a frequency graph of traffic, right? Why does this new domain that nobody's ever heard of, it doesn't have a profile on Google, it's not linked to any known people on the web, why is it all of a sudden getting all of this attention? That's something that defenders can look for. So let's get into a bit about asymmetric malware, which is the improvement, it's the evolution of where asynchronous malware is going. Asymmetric malware is malware that splits up receiving commands and sending data back. The simplest type of asymmetry is just using two different servers, getting a command from one website, sending it to another. But you don't have to limit asymmetry to just multiple machines. You can split your traffic across different applications, protocols, or really anything. In the most advanced form, asymmetric malware doesn't always need both channels. If you can custom particular malware or implant to only do one thing, then you sometimes don't need a command channel. Likewise, if you only want to change a setting or if you want to alter a machine in some way, you don't really need a way to exfiltrate data. So even though right now it's very much popular to just use asynchronous malware no matter what, people put beacons on machines even if they only want to do one thing. That's noisy, and with asymmetric malware, you can kind of get away from that habit of putting the same thing on every machine you want to communicate with. So let's talk about how we can do asymmetric malware on regular systems. Probably the primary example of asymmetric malware in real life is a piece of malware called Hammer Toss. It was written about fairly extensively by FireEye, and it's a free PDF download to check out. It was supposedly written by APT29, which is a Russian group. Now, one of the really cool features of this malware is that it uses Twitter to get commands. Every single day, the malware generates a new Twitter handle using what's called a PRNG. So it looks like it's a random stream, but really does, then you can generate the same quote-unquote random streams in 2 different places. So the malware generates a new Twitter handle and it visits it. And it uses that new Twitter handle to identify a place to download an image. That image then is decrypted. There's some encryption and steganography applied, and the malware is able to retrieve data back, or able to see what the attacker wants it to do. Once it executes those commands, it then exfiltrates data and takes the response from that, and it puts it on popular cloud storage providers. Right? This malware is really unique in that not only is there's no direct link between the attacker and the machines they're infecting, but it's really resistant to a lot of countermeasures. Even if Twitter knows that that a particular username is being used for malware, they can shut it down because the attackers are making a new one for tomorrow's command anyway. They only need 1 tweet a day in order to control all of their machines. So we wanted to do a little demo for you to show you what asymmetric malware might look like. And to do that, we needed a popular website. Since we didn't want to make anybody angry, we decided to make our own popular website. So if you want to check it out on your computer, it's notac2.info. And I swear there's no JavaScript messiness or anything like that. We're not trying to trick you. So what we wanted to show is that you could take a blog that you don't control as an attacker, and you can still use it to run your commands. So now if everything works out, you know, I have my fingers crossed. Live demos always get tricky. So this is notac2.info, right? And so it's just some content there, and there's a comment section like there are on a lot of websites, right? Now, when you're using a comment to run your malware, you can't assume a lot of things about structure, right? You can't assume that you're always going to be the first commenter. You can't assume that, you know, people aren't going to try to bury you or reply to you. So you have to have something to hinge off of. In this case, our malware username, regular poster, used a UUID. UUIDs are really nice because they're guaranteed to be unique no matter what. So if your malware is looking for this specific sign, you can be pretty sure that it's not going to be anywhere else. So just for the purposes of the demo and to make things simple, after the UUID we have a pipe, and then we just have a base 64 encoded command. So let's hop over to this PowerShell window and let's manually trigger our malware. Excellent. So this malware is very basic. It just points out that we're running code from a blog comment, and it just pulled up a little notepad window for us. So let's see, let's take it back. Excellent. So naturally, if you were doing something, you know, in real life against a real adversary, you'd probably want to do a little bit better than what we did here. The first of which, and the easiest thing, is not using a static sentinel value. Just like hammer toss, you're going to want to use a PRNG or another algorithm so that way you don't have to put the same UUID in every comment, because that's something that the person who runs this website could key in on and start to look for and flag. Likewise, you probably don't just want to base 64 encode commands, because anybody who recognizes that's base 64 will be able to take a look at it and see what's going on. So one of the things you could do is you could actually encrypt the command. And now Brandon authored a library called Check Please, and one of the things that you can do with some of the code he's produced is you can have malware that decrypts based on its computer name. So if you know exactly what computer you're going to infect with this asymmetric malware, you could encrypt your commands with that computer name, and that way even if people see this, they don't know what's going on. They can take it apart for you. Likewise, as fun as it is to buy domains like notac2.info, you're going to want to target a real site, something that's popular and something that's frequently updated, so that way you can continue to post your commands on new posts or something like that. Likewise, this is an asymmetric malware that doesn't have a data exfiltration channel, and so in most cases you're going to want to implement some kind of way to post data back to yourself. So one of the things you could do to kind of extend this, there's a really cool PowerShell command called send mail message. And I should clarify, for some people who are wondering why I'm keying on PowerShell a lot, it's because PowerShell is just great if you're writing malware for Windows systems, because you can run in memory, and it gives you a lot of easy access to administrative functions and some of the things you'd want to do. Send mail message is one of those commandlets that you really want to acquaint yourself with. It allows you to send emails using the Microsoft Office suite directly from the command line. That makes things very easy for you because people are sending messages every single day. They're probably not too rigorously inspected, and you can use that as a means to exfiltrate data without generating traffic that looks unusual. And on top of that, if you do some Google searching, you're going to see there's a lot of PowerShell scripts that are made to interface with a lot of common APIs and a lot of common sites that you might want to get data from. So it's not very hard if you want to make your own asymmetric malware to incorporate a lot of different vectors without doing too much work.
So great. We've introduced the concept of asymmetry. You go one place, but that place might send you somewhere else. You have one place in mind, and you also have a backup place that's different, and you use different channels. A good example of that was Zeus VM. Who's familiar with this piece of malware? Good. Zeus VM was a pretty cool banking Trojan. There was a good piece by Jerome Segura on it. There was a security researcher who noticed a strand of malware was pulling down a JPG on a server that we knew was hosting other malware components, so a C2 server. So there was malware on a computer, and it went to this malicious domain name, and it pulled down a JPG. And this was the image. Beautiful sunset, right? But as it turns out, that actually had some data in it that pointed to another domain. So if you go to packettotal.com, for example, this is a sample that uses that has network traffic for a piece of malware that did pull down this image. So who's heard of Packet Total before? Okay, great. Yeah, it's a great resource. So if you actually upload the packet capture to packettotal.com that has this information, you can see in the transferred files section the JPEG that was downloaded. And then if you switch over to the HTTP tab, you can see all sorts of different hosts that were called as a result of that JPEG. So Russian domain names, etc. So that's an example of asymmetry, right? You pull down an image from one server. Why? To get another server, to go to a cloud provider, to go anywhere else. A blockchain is another really interesting use case for asymmetry, and it's kind of scary how nasty it can be. Bitcoin, for example. Very little things you can do with Bitcoin, right? Essentially, you can just pay people and offer multi-sig verification for those payments. But op return is one of the calls you can make, and that allows you to store some arbitrary data, some metadata. And this has been kind of a huge debate in the Bitcoin community, whether people should be able to write their name on the blockchain or a birthday or something menial like that, because it's adding to the overhead of transactions. The blockchain gets longer. But if you're putting arbitrary data on the blockchain, what does that sound like to you? Everything on the blockchain is permanent. You can't kill one C2 server and have the blockchain go away. It's a network of miners that host it. There are several different websites, and more are growing, that scan the blockchain, that tell you every single transaction on it. If you can piecemeal different transactions with arbitrary data that form together to make a really nasty command or to beacon out somewhere, it's very hard to stop. You concatenate these, you get the shell command. That's just for Bitcoin, and that was the dumbest cryptocurrency initially. And here's an example. This is a Twitter account I found. I'm not sure how big it is. It's only 203 followers. But this one posts the human-readable op return metadata information for recent transactions on the blockchain. So this is just one that came up. So if I put, some encoded command on there, how are you going to stop that? It's very, very difficult to stop. Ethereum is even more powerful in this regard. Ethereum is a Turing-complete language. You can do whatever you want on Ethereum. So there's more places to store information, arbitrary data, etc. So smart contracts, there are data fields that you can put binary data that can be interpreted by malware. And again, it can serve as a C2. Your C2 infrastructure is the blockchain. You don't need necessarily a server anymore that you pay for and have it taken down when you have a decentralized server. Every single miner is hosting your malware, is hosting your C2 channel. This is dangerous. IPFS is interplanetary file system leveraged by Ethereum. Here's a Medium article that discusses it at a high level. You can have websites that are completely distributed, websites that have no origin server, websites that can run entirely on client-side browsers, websites that do not have any servers to talk to. What does that sound like to you? Sounds like a really dangerous C2 opportunity. It used to be centralized, but now you have asymmetry, but beyond asymmetry, you have decentralized asymmetry. So again, it's a distributed file system. You can address the content you want by a hash, and it'll traverse, and it's version controlled. So anything you want, it's always going to be there. Any malicious code. And who's going to take it down? Who's the admin? Who's the government that can take down something on the blockchain? You can't, right? This is kind of the double-edged sword of transactions of the blockchain. So attribution gets very hard. If you send your initial payload from some random computer, and then it starts communicating back to the blockchain, how are you going to figure out who did that? It's very difficult to do. It's not like something you could subpoena and get network traffic from. It's the blockchain. So attribution is very hard with this kind of asymmetry as well. Now I'll talk about air-gap systems. So air-gap systems are systems that are not connected to any other system or the internet. There's a gap of air where a wire would be normally. No communication. It's a computer normally that has information you don't want anywhere near the internet or any other system. It's easier to place malware on these systems than it is to get information off of them. So if I'm in range of it on the same floor even, I might be able to get a USB inside one of these or find a clever way to get it on there. But how am I going to get data out of that, right? To do that, you can think asymmetrically. Sounds. This is kind of clever. You guys remember those mosquito ringtones? These air-gap systems have speakers. Speakers are a form of communication with the outside world. If you have a recording device that can capture sounds that are inaudible, you could exfiltrate data from that air-gap system. So it's air-gapped so long as there's still channels of communication with the outside world in air-gap systems. Sounds are a really good example of that. If it has a speaker, it's not purely disconnected from the outside world, and you can hear it across the hall too. And I'll pass it over to Andrew to talk about refresh rates.
So every screen has a refresh rate, which governs how often the image on the screen is updated. Now, some computers all have refresh rates that run slightly differently, but when you get to a high enough refresh rate, the ones that are used on most computers, you're not actually going to notice a difference in normal operation between small differences, between small shifts in refresh rate. But these differences would be noticeable to a camera that is recording it and has a very high refresh rate. So take NIR command. You may be familiar with NIR command because it's used by a lot of system administrators to do a lot of different functions when it comes to changing settings on a machine. Well, NIR command gives us a really cool setting called set display. Set display gives us a lot of different options, but you can see right towards the edge that you can set the refresh rate. So a malware could ostensibly use this code and shift a refresh rate very slightly, not so much that it would be noticeable to someone who's watching the screen. If you can modulate even only between two different frequencies, then you can create a binary channel, and a camera that's able to record the screen could pull this, and they could use the differences as a way to send and receive information. So one of the things we wanted to specifically highlight is Bluetooth, because we're seeing more and more Bluetooth and Bluetooth-enabled devices. So Bluetooth does run the problem that you do need to be fairly close to a particular machine, but the particular range is definitely going to vary, especially because Bluetooth isn't the only culprit, and as we're seeing more and more of these small embedded devices start to show up, we're going to see systems that not only have Bluetooth antennas, but they also support Zigbee and other common ways of interfacing with these different devices. And the problem is that they all work really well as a way to send data without a network connection. So one of the things we particularly want to emphasize is that despite the popularity of bring your own device policies, where employees can bring their devices from home and use them for work, they shouldn't mix with air-gapped systems. If there can be a device that is potentially attacker-controlled within range of a system that you want totally isolated, then you can't consider that system to be totally isolated. It's an asymmetric channel, and it's definitely more complex, but it's one that attackers will recognize and start exploiting. So if you want a system to be truly air-gapped, then you're going to have to start implementing more stringent policies about what devices are allowed near it, as well as potentially looking into more advanced options like actually shielding rooms that contain air-gapped systems. Now, you may think that stopping Bluetooth is fairly easy, but it may be a bit more challenging than you're expecting. So a lot of systems nowadays have a chip that looks exactly like that. That chip is a standard Wi-Fi chip, but it also has Bluetooth capability. So it's not as easy as pulling a specific module out of a computer or not allowing USB antennas or something like that. To block Bluetooth in most systems, assuming you need Wi-Fi, which is very common, you're going to need to implement software-based restrictions. And now, as most administrators and defenders are aware, when you have to go to the software level in order to defend something, things start to get tricky because inevitably exceptions are made or policies aren't applied correctly, and attackers will find those, they will recognize those, and they will leverage those. Likewise, you may be thinking that if you have Bluetooth on a system or another antenna like this, that you could set up some synchronous communication. And that's definitely true. But synchronous communication through one of these channels would probably be both very challenging and very noisy after a while. So if you want a truly covert type of malware, you're not going to be using something like Bluetooth as a synchronous channel. So let's talk about IoT, the Internet of Things. So the Internet of Things is incredibly popular, and we're starting to see that the Internet of Things idea and mentality is affecting organizations. Right, we're starting to see organizations incorporate smart coffee makers and smart light bulbs and smart meters and smart printers that have a host of sensors, and you can not only configure locally, either over the internet or with Bluetooth, but you can also query from some remote place. They offer APIs, that way people can configure these devices from very far away. The most interesting IoT devices to us are the ones that have both Bluetooth and Wi-Fi capability, as well as the ability to check or manage them over a remote API. So what an attacker can do is something truly crafty. They can use a Bluetooth channel from an infected device to set a value on these Internet of Things devices. They can then query that value from a remote API or from a different place, and they can use these settings that they can configure as a means of data exfiltration. Take a smart light bulb, for example, which usually allows you to change to a whole host of colors. A color is represented as an RGB value, which is really just 3 bytes. While it's not particularly efficient, an attacker could use Bluetooth to rapidly change these 3 bytes and then query those bytes from the remote API. That makes for a really cool opportunity because there's no direct link between the attacker and the data that they're stealing. Moreover, even if a defender recognizes that all of a sudden an Internet of Things device is being queried rapidly or being set rapidly, they don't immediately know which system is doing it because from what we've seen, Bluetooth isn't really a monitored channel in most organizations. So they're going to be completely blind to that until they start to implement get new hardware and software to kind of find these things. Moreover, like we were talking about before with air-gapped systems, IoT, the solution is not just make a new Wi-Fi network, because the device doesn't have to be on the same network if you can communicate over Bluetooth or something similar. And it's not just a matter of putting them in different rooms when things like Bluetooth Low Energy has a 100-meter range. Especially, in the great city of New York City, 100 meters can be an entirely different building. So it's not just a matter of securing a particular section of your organization. So let's look at a case study. So let's consider an opportunity where an organization is fairly secure but falls victim to a more advanced malware that implements some asymmetric tactics. So let's consider the super secure organization. So like a lot of modern workplaces, everything the employees are doing on their computers is monitored, and also like a lot of companies that we see, they allow BYOD. And they're smart, and they don't want to put those devices on the same network as the rest of the corporate devices, so they implement a Wi-Fi network specifically for them, and they have entirely separate hardware for the BYOD to access the internet. Like we see a lot, that they implement one of these site categorization tools, and they only allow employees to visit pre-approved domains, ones that they're sure are both business relevant and are going to be generally safe. To get even more insight for network appliances, they use HTTPS decryption at the egress and ingress points. So even if something is happening over SSL, they can actually take a look into that, and they can use their indicators of compromise against that kind of traffic. So if you're a normal red teamer, this would probably be the workflow that you would go about. So you would go and you would set up a C2 server, and you'd probably put an SSL certificate on there, so you're not going to be detected immediately. And let's give the standard attacker the benefit of the doubt, and through social engineering and some magic, they do get some code to run on a victim's machine. Eventually, the defender's going to see these attempted connections to a new domain, right? Since they have SSL decryption, they're going to be able to decrypt that traffic, and they're going to see PowerShell commands. This, of course, is going to set off many alarms. People will be woken up in the middle of the night, and the defenders will quickly work to identify what machines have been infected with this and work to remediate as soon as possible. And the attacker is going to be left disappointed because they didn't get domain admin, and writing an impressive sounding report is going to be very challenging. So let's consider an asymmetric attacker. The asymmetric attacker isn't going to go set up some C2s, but rather they're going to identify some blogs, some news sites, and some other places that are probably already being used by a lot of the organizations, right? If most organizations have a marketing department nowadays, and that marketing department is heavily involved on social media, so they might identify that as a particular way to host commands. Through a little bit of social engineering and some research, an asymmetric attacker can likely identify what kind of cloud storage or providers are being used in the environment, and start to tailor malware for that. So they're going to write malware to get commands from, say, the most recent comments on a blog, and they're going to, like we were talking about before, use a string that changes daily. So there's not a one static indicator anywhere. Once they've identified who they want to infect, they're going to start encrypting their commands with AES and using, say, the machine name as a key, because that's not going to be something that's going to be changing very quickly. And a quick shout out to Check, please, for making that so easy. The asymmetric attacker is going to win in this scenario, right? Defenders are going to see traffic, and since they have SSL decryption, they're going to be able to see the plain text traffic, but they're only going to see victims talking to known good servers, right? Even if they do start to key in that there's something going on in their environment, they're not going to see any indicators right away that directly identify who the attacker is. Making this more complicated, assuming the asymmetric attacker did some research, they can't just resolve this by blocking certain websites. This is a much more challenging malware to defeat.
So now we're going to talk about defending against this. And honestly, our core recommendation here is to block traffic to popular websites. So that includes Twitter, Reddit.
Shut it down.
I'm very serious. This is not funny. ESPN comment section. If it allows comments, you can't allow your employees to go there. Not. Is quoting Borat still funny? I hope so. But honestly, there's not really a good measure against this is the issue. So a lot of times it's going through popular websites that I just mentioned, popular blog posts. You can't block that, but you can try, especially when they're going through several different ones, not just one. You can do your best. We'll give you some recommendations. While you can't restrict traffic on client, workstations, servers are a little bit easier to do this for. Why is someone going to reddit.com or whatever website, NewYorkTimes.org, from a server? They shouldn't be. Servers most of the time are not internet accessible, which is a good start, but you can implement really strict controls on those at least, and servers host the most valuable data in most instances. Watching your behavior, it might be a very popular website, but if a specific user doesn't go to that website ever, then it doesn't matter that it's a popular website. It's not a popular website to that person. So if you have some good capabilities to recognize behavioral patterns, then shifts in frequency will be telling. This is unusual that they started going to this site over this site all of a sudden and with such frequency. And finally, SSL decryption does go a long way. It's tough to implement in a lot of cases, but if you're able to get visibility into all the traffic and you have a good mechanism, AI, machine learning, to analyze that traffic, you'll be in a better place to protect against one of the hardest attacks there is to defend against. Yeah, so normal traffic to websites, when decrypted, will look different than strange traffic to these popular websites when decrypted. And that's it. I'm Brandon Arvanaghi. It's my Twitter, and this is Andrew Johnston. It's his Keybase. So if you have any questions, we're happy to take them. Thank you.
Regarding AI systems that are used to prevent asymmetric
Yeah.
infections. Do you have any data that speaks on the effectiveness of these systems? Like, for example, CrowdStrike or Darkness,
Sure. So I don't think either of us are familiar with the accuracies off the top of our head. And as you can imagine, like most things in machine learning, this is an active area of research. For a quick plug, I'm sure if you look at some of the FireEye documents, they'll have some great case studies on how they've implemented these types of solutions and how they work to both identify malware and to do so with great accuracy, even in the face of things like obfuscation.
Do you think you could put the blockchain example into context? Is that like an expensive attack to pull off for an attacker, do you think? And then as well as like, can you think of any mitigations against it?
I'll defer to Brandon for that.
Yeah, so the challenging thing, there's a lot of different ways to interact with the blockchain, and again, a lot of these are just going to be over 443 traffic, sites that enumerate different transactions. Reading from the blockchain is very easy to do. Writing to it can be a little bit more challenging, but if we're talking about getting commands, they're always going to be there forever for everyone. So reading simple, writing can be a little bit more challenging. Yes?
You mentioned something about your second slide about servers not being internet facing.
Yeah.
Or something.
Yep.
Yeah. So what would you say to organizations that are moving to all cloud? So that infrastructure as a service, where their servers aren't internet facing.
So if these servers are actually hosted in the cloud, is that the idea? If they're hosted in the cloud, then I mean, it depends on what the cloud service provider is doing. A lot of them won't allow arbitrary access to other systems that they don't need to be. You have isolated clouds, you have public clouds, so it all depends on what you're going for. If it's a server that needs to talk to the clients, then it's going to be internet accessible, obviously. Yeah. Yes?
So through the asymmetric malware, you still have the same pattern when you pull down the data. So what about taking that pattern across the text server actually pulling down? So you still will have, like, for example, the payload some degree, right? So you can take that through like how detection is right? So to some extent you can block it from the standpoint of having the standpoint, isn't it?
You're saying they're similar.
So the model will read basically specific patterns in the text.
Yep.
You have set format, right? You have like the GUID, you have the payload, and that won't change in the malware. So if an endpoint protection system will be able to identify a pattern, will be able to actually block all the rest of it.
Yeah, so that's a good point. The major part of asymmetry, though, is that we won't rely on simply one server in the first place. So we might have another vector like the Wi-Fi or the Bluetooth or something like that. So if you block that one avenue, it's an 8-headed monster, and we talked about decentralized C2s as well, which are even more difficult.
The payload form is going to be the same across any communication method.
Well, it depends. It depends it depends if you're concatenating payloads, if you have a pseudo-random number generator. It can vary based on the source of the asymmetry, based on where you're pulling the data from. Yeah.
Mind if I jump in on
Yeah, go
this?
ahead.
Something? So what we've seen as red teamers is that oftentimes it's fairly simple to get code execution on one machine. So in terms of getting a payload onto a client, that's not really a concern. There's a lot of different ways that people can do that. The challenge really becomes how you maintain that payload, right? If the payload isn't caught when it's first deployed, then it's really just it's all about endurance. So with an asymmetric malware where you're spread across multiple channels, it's going to be a lot harder to detect. Sure, there's still traffic that's receiving commands and sending data back, but when it's spread out across a number of different servers or applications, it's not going to be as easy as looking for a single weird IP address or domain name. And oftentimes we see that defenders are looking for those kind of indicators, looking for new domains or uncategorized domains. And we're trying to argue that that's not going to be, that's not an assumption that you can make anymore with this new advanced malware.
How successful have you been with using asymmetry?
With using asymmetry. So asymmetry is, oh my God.
Lance.
Yeah. There we go. Yeah. So asymmetry is definitely it's very successful when it's deployed in terms of for an attacker. The challenge becomes identifying what kind of traffic looks normal for a business if people aren't regularly communicating with a specific cloud storage provider and your malware really hinges on that. That's not really something that's going to work very well. So what an attacker needs to do is take a profile of the environment that they're operating in, and potentially do some really good OSINT to try to identify what kind of systems they need to do, and then write custom malware. Right, using these Cobalt Strike and Meterpreter and PowerShell Empire, they're great, but they're very much kind of cookie cutter. And we're going to see more malware that is tailored to the environment, and likewise, red teamers and the good guys have to start doing the same thing and making more tailored malware, because that's what we're going to see the bad guys doing.
Two things. One is for the Bluetooth. You said there's a 100-meter range. So in a city where there's a lot of concrete and this and that, is that for 100 meters in a city with condensed population and buildings, or that's the ideal line of sight distance?
So for Bluetooth in particular, yes, that's the maximum distance. So you are going to have some trouble with interference and with things like concrete. But also in the city, you have the converse, which is a very dense population. So even if it's not 100 meters, even if it's only 25 meters, that may be a different building. In a shared workspace, that may be a different office. So it's still very challenging. Looking at protocols like Zigbee, which actually use a mesh networking concept, and information's relayed until it reaches its destination, the actual range could be a lot longer.
For the second one, you mentioned about air gap systems with USB that can be used as an attacker.
Mhm.
If the auto update is not enabled on the operating system, is there any other way they can use the USB to have the user run something?
So there's a tool called Rubber Ducky, and essentially what it does is it looks like a USB drive, but it emulates a keyboard. And so anything that can be done from a user perspective can then be done via the Rubber Ducky.
Doing this is like a red teamer using the popular websites. Is there any way you're breaking the terms of service of
Yes,
these websites?
yes. Yes. Did you notice that we wrote our own website today?
Yeah.
That was not for fun.
Use this method as a real red
As a white hat, you cannot. You definitely will get in a lot of trouble too. But
Yeah.
bad guys don't care about that. Yeah.
And it probably depends on the website and the terms of service. But yeah, we don't recommend going to all of your social media sites and start using them as a C2. I'm not advocating for that. No one's advocating for that.
Yes.
How do you solve the problem of dealing with the systems that are connected out to the internet and the loss of the network? How do you continue to hide your transmissions out?
So through a
Through what network? Sorry.
If you're connected, your target is inside of the lossy, it only has connection to the lossy networks, and you're piping out to other games or something. You want to get your commands out on a regular basis so you can figure out what's going on. How are you guys going to solve the problem of closing that inside of whatever traffic is coming out?
Okay. I'm having a little trouble hearing you. I'm happy to. I think
think-
we're right.
I think
You
like
want
a
to talk to us after that? Yeah. Just meet up with us. I think that's good.
So we are out of time.
Yep.
All right.
If you have any more questions, just find them. Let's
Mhm.
find them again.
Okay.